uh, very handsome amount. So today we can talk about the from where you are basically. You are attending the classes, but I don't know from where you are attending. So first is the Ahan Bashu. Is he here or he has left already? Logged in. Ahan Bashu,
Yes, sir.
so you are from which place?
Sir?
You are from which place? And where you are
Sir, I
living?
am from Bongaon. Bongaon.
Bongaon. Okay. So connectivity is good there?
Yes, sir.
Connect. Okay, no problem. So Amisha Parveen.
Yes, sir.
So you are from which place? Huh? Baripur.
Yes, sir.
Okay. Anando Chakraborty.
Yes, sir.
So you are from which place?
Sir, I am from Salt Lake.
Salt Lake. Okay. Arnab Chakraborty. Arnab Chakraborty. Hello. Can you hear me? Arnab. Arnab. Network problem. Asmita Mukherjee.
Yes, sir.
You are from which place?
Sir, Nagtola.
Nagpur. So how you are enjoying lockdown? Are
Sir,
you now going out or a lockdown in home due to corona? Or you
no,
are
no, sir, I
family?
go out sometimes.
Okay. So what is the situation there? Corona situation. Is there any number of cases or it has gone?
No, sir, here everything is like everybody is going out, and sometimes people don't even wear the masks and all. So,
No. So that's the problem.
and people use
Some
public transport like before Corona only.
uh, no problem is that many people are so bold enough that they even cannot have the marks, and that's the problem.
Yes,
However,
sir.
the corona cases are going down, and the
But it went
vaccination
down, but then now it's again rising a bit.
again rising. There are some cases coming in into the different states basically. So actually, during this corona, just 1 month ago, I visited the Punjab, Manali, Shimla. So there I found that the people are not so bothered about corona, especially in Punjab. I have seen that even they don't believe in corona.
Yes,
So,
sir.
so that's the problem. So it can be transport from the other state to our state. So that is the main problem.
But even in Kolkata, in the outskirts, people don't believe in Corona. They don't wear mask. They don't take it serious.
Even the actually corona is a very mysterious disease. Somebody believes, somebody don't believe it. So that is the main problem. Okay, but we have to take the protection.
Yes, sir.
Uh, okay. At least masks should be mandatory for all when you are going out or taking the public transport. However, fear is gone. Whatever the fear appeared during the starting period of this corona, but that much fear is not now. But however, we have
Yeah.
to get the protection.
Sir, when will the college reopen? And will we have offline classes?
Actually, um, so far the all India basis, central government also is not a position to open the institutes. Mainly the problem is the hostel etc. life. So they are not even taking that fix. And thereby the state government also is not taking any risks. Everything is actually going on except the education system. Okay, all other
Yes, sir.
system is running, but education system is now online. So they
Yes,
believe
sir.
that it can be done by online. Okay, actually main problem is that students, they don't believe on have the confidence on the students whether they will maintain the situation or not, they will worsen the situation or not. That is the next problem. So
But sir,
government is not
schools
taking.
have reopened from 9 to
Ah,
12.
that is the actually school people are disciplined. They are still not 18 plus. They are 18 minus, so they are not adult in that sense in terms of rights and the constitution. So they can be treated as a minor. But as you are adult beyond the 18, so we actually the administration cannot force everything there. So that is the main issue is there. So however, I don't think the physical system uh, can be replaced by the online education. Online education is becoming now very monotonous to you. Okay, so if it opens, then it will be better for you.
Yes,
Already
sir.
medical college they have opened.
Yes, sir.
So all
They
medical
even
college
had
have opened.
offline exams.
And but you are enjoying the online exam system, no? That is the benefit. You are enjoying the online education exam system. Okay, let us see what the central government do. When the central government will do something, then the state governments will follow. So that is the main issue. Let us see what they do.
Okay,
Then
sir.
we'll expect that it will be after the election it will open.
Oh, okay, sir.
Okay. Thank you. Devanik Borua. Hello. From where you are?
Yes, sir. From Behala.
Behala. Gopal Medda. Hello. Gopal Medda. He is not there. Jasmuddin Mondol. Jasmuddin. He is not there. Jayanta Mondol. He is also not there.
Yes, sir.
Okay. Jayanta Mondol. From which place you are?
Yes, sir. Bahajuddin.
Bagayati. Which side it is?
Highland Park.
Island. Then Jyotirendra Sarkar.
Yes, sir.
From which side you are?
Sir, I am from Dattapur.
Dattapukur.
Yes, sir.
It is Barasat, near Barasat.
Yes, yes.
Mousumi Soren.
Yes, sir.
From which place you are?
Sir, I am from Jongipur, Murshidabad.
Murshidabad. Jongipur, Murshidabad.
Yes, sir.
How is the situation there?
তো এখানে সবাই ঘুরে বেড়ায় উইদাউট মাস্কে।
হ্যাঁ, ওটা তো ভিলেজে নেই। ভিলেজে এটা নেই আর কি। আর কি করা যাবে যেখানে যাবে।
অতটা কেউ অ্যাওয়ার না, মানে যারা একটু সচেতন তারা মাস্ক ঘুরে বেড়ায়, আর যারা এমনি পিপল তারা উইদাউট মাস্কেই।
হ্যাঁ, ওই আর কি মিক্সড প্রবলেম। আগে নিজের প্রোটেকশন নিজের কাছে। নয়ন সারেন. হ্যালো.
Yes, sir.
You are from which place?
So I'm from Kharagpur.
Where?
So Kharagpur.
Or Indila Haldar.
Yes, sir.
You are from which place?
Sir, I'm from Haldia.
Poromi Das. Hello. You are from? Okay, network problem. Sandra Hussain.
Yes,
Okay.
sir. Yes, sir.
You are from which place?
Sir, I'm from Kolkata itself, but I'm currently in Odisha.
Visha. On tour.
Yes. Sir?
On tour or job or
No,
something?
sir. I used to live here. My father works here.
Okay. Oh. Sahil Singh.
Yes, sir.
Sorry, sir.
Sahil, from which place you are?
Sir, I'm from Pratapgarh, Uttar Pradesh.
Which side it is? Pratapgarh? Which
It's inside of.
train goes there?
There are a lot of trains. I think
Name of the one train?
Netaji Subhash Chandra Bose. Something. Actually, initial name was Kalka Mail, but recently it has been changed.
Okay.
Train name is
Oh,
called
okay,
Netaji.
old name. Kalka is going there.
Yeah. Yes, sir.
It is in main route, main line then. So it is UP. Nearby famous station? Which station? Nearby Kanpur?
Prayagraj, sir.
Agra. Okay. Nearby
No,
station.
sir. Prayagraj.
Agra.
Allahabad, sir.
No. Kalka will Kalka. I think Kalka does not stop into the Pratapgarh. Is there any stop Kalka in Pratapgarh?
No, actually, sir, I generally take my train from Prayagraj.
Prayagraj.
Sir. The initial name was Allahabad. Now it is Prayagraj.
Oh, you are taking the recent name. So old name is Allahabad. Oh, so you are changing from Allahabad. So nearby Allahabad then. Okay. Okay. So how is the situation there? Is there any corona or not? So
No, sir, I think everything is fine.
Fine. Village or semi-town? That is Pratapgarh.
Maybe semi-rural or semi-urban.
Semi-rural, urban, semi-urban. Okay. Okay. Sombit Biswas, you are from which place? Belgaria. Okay. Shahrukh Ali,
Yes, sir.
you are from which place?
Sir, Haldia.
Yeah. Snehashish Banerjee.
Yes.
Hello. You are from? Banerjee tried to respond, but I think there is a network issue. Snehashish Banerjee. Okay. Shobik Nag. He is here, no? Shobik Nag. Hello, Shobik.
Yes, sir.
You are here?
No, sir.
Okay.
Sayon Nag, I think.
Oh, Sayon Nag. Yeah. So you are from which place?
I am from Sipur, Howrah.
Subroto Dalal.
Yes, sir.
You are from?
Sir, Kotulpur, Bankura.
Bakura. Why instead of Bakura you spell you just Bankura? What would be?
Bankura.
Huh? Bakura. It is Bakura basically.
Sir, yes. In Bengali, that is Bankura, Bakura, but in English, it comes Bankura.
In English, Bankura. Oh, Tamil. Yeah. Okay. So, where is the route to go there? From which place you are
Sir,
going?
from Howrah to Arambagh, sir.
Then?
Howrah to Arambagh by train and then by bus.
So it is very near then.
Yes, sir.
It is very near. So, how far it is from Jayrambati?
From Jayrambati, it is 1 hour by bus.
It is very near to Jayrambati. Okay.
Yes.
Okay. Swarnodip Saha,
Yes, sir.
you are from which place?
Sir, Dinhata, Coach Bihar.
Dinhata, Coach Bihar. Okay. So now the photograph shown in your profile. So whose photograph it is?
Sir, Richard Feynman.
Richard Feynman. Okay. What is his contribution?
Sir, in quantum electrodynamics mainly.
Feynman. F-Y-N.
F-E-Y-M-A-N-N or single N actually for F-E-Y.
F-E-Y.
Yes, sir.
Feynman. Feynman is basically quantum mechanics.
Quantum electrodynamics, sir, I think.
Quantum
electrodynamics.
So what is the difference between quantum mechanics and quantum electrodynamics? Which side it is taking? Quantum electrodynamics?
Sir, basically, I think electrodynamics and there is obviously some difference in mechanics and electrodynamics means that part which basically we studied just like in this semester we have classical electrodynamics, field theories, all of this. So I think that quantum approach, though I don't know all the details of quantum electrodynamics, but that type of parts, that means the classical approach which is taught here, field theory, that electrodynamic, that quantum part basically.
That is called basically crystal field theory, I think. That is the name basically. So that is the domain of basically quantum application of the field theory in quantum mechanics. So Feynman has contributed this very mathematical subject, is very mathematical.
Yes, sir.
Quantum mechanics basically, what is the basic difference is that quantum mechanics is basically probabilistic approach. Everything is probabilistic approach. Normal field theory, it is confirmed case. There is no probabilistic approach. This is the basic difference between this. And that is called the crystal field theory basically. That is very difficult subject, very complicated issue because it acts on basically quanta. I think you know what is quanta. Quanta is basically, quanta particle is basically electron, photon, phonon, like that. All of these are called the photon. All of those are called the quanta. So when the field theory acts on that interaction between them, and that's called the quantum field theory.
So Feynman is basically famous. That means not famous, but he is quite renowned for his 3-volume book, Feynman Lectures on Physics. I think all have heard about.
No, what are the topics there?
That means in that books Feynman discussed, or Feynman was one of the best physics teachers of all time. He delivered the speeches in the universities. So that was basically that lectures.
So he covered the physics basically domain, but his contribution is on the crystal field theory or quantum field theory, whatever you say. So why you have so much attracted on him? Why? What is the basic attraction? Books or something else? Hello.
Sir, I don't
Sorry.
understand. What have you told?
Actually, why you are so much fan of him, of this Feynman? There are other scientists also. So why you are specifically what attracted you to become a fan for the
Basically,
Feynman?
his lectures, his books have fascinated me most, and
Okay.
I also studied some life. That means the biography of Feynman, which have attracted uh,
Oh,
some aspects of his life which has attracted me. So that's why
okay.
overall, Feynman.
Yeah, overall, actually,
I
overally, it is ideal
Feynman.
for
Yes, sir.
but what you have now, I'm going to the point. So, what you have found this type of things in your Jadavpur University in engineering course? Have you got any taste of that type of course in Jadavpur University, or what are the basically you are getting from here?
So, sorry about Feynman. I am fascinated to him before coming here. Also, I have studied about him uh, in in engineering. I even we don't come across even Einstein also, but some scientists are always. What I could tell, because engineers do not deal with the scientists or their works directly. So, but even then,
Okay.
actually, the engineering course doesn't make me fascinated towards Feynman. He has become
So
my
now,
favorite scientist beforehand.
question is already you are in second year. Whether you have liked it or not, what is your whether it is in tune with your expectation or not? That's why I'm asking.
Sir,
So
this course,
yeah, the engineering course,
yes,
what you
sir.
have dreamed and what you are getting as far as education concerned, not for other aspect. What the
Yes,
education
sir.
we are giving you, whether that is
Yes, sir.
interesting for.
Obviously. Yes, sir.
Okay.
Obviously.
No,
And the
basically,
most
uh,
and the most fascinating which have been proven. I don't know whether I am quite have efficient in that subject or not, but electrical
yeah.
machines fascinates me most. But I don't know. Let's see. And other subject
Actually,
also
I don't teach
interesting.
directly electrical machine other subject. However, I know all of the machines. Here, the other teachers they actually teach this subject. But main problem is that uh, you cannot find a good book in machines. That is the main problem. What I have observed. Actually, a good book so that based on that book you can learn machines. So there is a lacking of the good book. So now question is why, especially from Indian authors, there are so many authors. They have written the books, but main problem is that there is no quality books from Indian side. And foreign authors they have written the books, but actually they are not so much interested into the numericals. So for all the foreign books are lacking the numericals. Indian books are full with the numericals, but they are lacking in the theoretical book. So that is the main problem into the side of the book. Even in internet also, if you cannot find much information about the electrical machines. Main problem is that electrical machines, it is a conceptual thing basically. You have to develop concept. Otherwise, it cannot be actually. It's not a actually uh, note in a note. You cannot confine a machine. Okay, it is beyond the note. So you have to, and a sequential study is required. Okay. However, you have to learn on the machine because it is a major part in electrical engineering. Basically, major part. And other part is the different kind of circuit, etc. I mean, there are four various pillars on which this electrical engineering is standing. One pillar is the electrical machine. Another pillar is the circuits, all the type of circuits. And another pillar is the power system. And another pillar is the digital system. That means the microprocessor, etc. All of this. So if you want to be very good in electrical engineering, then you have to be master on that. And the gate question is heavily conceptual based and in depth. So I find that day by day, electrical engineering of Jadavpur University are not doing so well as earlier. We have found 10 years back. So there was a very good rank, even third, fourth, fifth, we have got from this department. But today, even within 1,000, we cannot find the student from the electrical engineering department. Maybe they are not interested, they are getting very interesting or very fascinating job, very high salary, so they are not interested in further study. Or maybe that they have become so bored with the engineering courses during these 4 years, so even they cannot dream of further study. Most of them go for the job. Maybe different reason is there. But one reason is definitely is there that I cannot find the students, those very few students I can find that they have not appeared for the gate. Main problem is that they are appearing but they are not getting their success or excellence there. That is the main problem. So I don't know why this is happening. Basically, why this is happening. But if you want to study further, you have to take a very good score. And gate question is basically very typical question, fundamental question. You have to do well there. Unless you do well in fundamentals or understanding part, you cannot do well in gate exam. Now today, last day, actually what I have discussed today, so I have learned because we are taking the classes, so we should know each other. In physical mode, we can see, we can talk some topic beyond your syllabus. So today I have done that. Still, there is a time. Today I will go for my course today. Okay. Now we are starting our course. Actually I have mailed you all the vector diagram what we have done basically. So now we are going for classes and presentation mode. One thing I can say that due to Jamboard, somebody has told me that if we teach in Jamboard, then it will be very printing friendly. You can print it easily and send to you, but I cannot uninstall this Jamboard. It has become a very complicated issue now. I cannot use the pen tablet, so again I am taking the course in PowerPoint like that. Even I don't take the PowerPoint because I will send the material. That's why I have not prepared the PowerPoint. However, I have from the books I have collected the material, and henceforth we will go for the class accordingly, so that some material will be along with you, because all of you don't have the books, you are in home. So if you have some material, then you can study later and you can understand by yourself. So that's why I have gone for this type of method. So that will be beneficial for all of you. Even exam, you have to appear the online examination system, so you can have the material in your hand. So that's why that is very important. So today, henceforth, I will teach the machine like that way. Even if you have any doubt, you can ask me. So this is the vector diagram I have mailed you. And you can see that all of these connections here. But one thing I can tell you that if I give you the question, then you have to answer according to my method, what I have drawn, how to draw. So in that method you have to answer. Here is a summary, or you can say it is merely a list. So it's a very simple way they have described. But suppose here you say that one drawing. So they have described A, B, C as a vector diagram. It has not given any direction of the vector diagram with the arrow. So but in actual my part, you can see that I have always used some vector in physically given the arrow. So here only short representation is there. This is not a actual. So in actual sense, you have to do this. Okay. So this type of answering will not be getting for the good score. I will give you the score, but heavy marks will be deducted if you follow this chart here. And next, also you have seen that a transformer. Last class we have done. So how to parallel to different vector group. One is YD11, another is the DY1. So how to make them in parallel. So what the modification we should do, so that has been discussed in the last class. And that material also I have given you here. So you see that, so this is written, it is taken from the books. I have explained in the last class. Again, I will not do that. So you can have this from this material. So that can be understood. If you don't follow there, again you can read it. I will send it to you. Now we are going for the another connection that is called the. You have. Can you see the material here? Hello.
Yes, sir.
Okay. So now we'll go for three phase to two phase conversion. That is, scientists Scott have discovered this, so that's why that is called the Scott connection. So now my question is, there are three phase. Okay, you know what is the three phase. There is a phase sequence also. Now, if from a three phase, one phase is out, then how many phase remains there? Can you say? If out of the three phase, one phase is out of the system, we cannot have that one phase. Remaining is the other phases. So, what are that system? That can be told as a two phase.
Yes, sir.
So,
No, sir. Two phase means the two phases are displaced by 90 degree.
So three phase means it is a 360 divided by 3, okay? But two phase is 180 divided by 2. 180 phase plate divided by 2. That is called the two phase. So two phase, it is not a very simple that from the three phase you cannot have a two phase directly. If we remove one phase, then the remaining phases will be two phase, not like that. From three phase directly we can have a single phase, but not the two phase. So two phase is basically when the phase 1 and phase 2 will be out of phase 90 degree. I think you have understood what is the out of phase 90 degree. So there may be lagging, there may be leading, depending on the selection. But lagging leading will be 90 degree, not 120 degree. Okay? In case of three phase, it is 120 degree, but in case of two phase, it is 90 degree. Now, these two phases are normally used in practically different harness system in the factory. So that's why we have to know how this is obtained. Basically, two-phase can be generated by the generator, but industrial generator is normally three phases. However, if you need the two-phase, then how to do that? So that is the Scott connection. So now we can go for directly the system here. So here is a figure you have seen. So this left-hand side, this is a source basically. This is a transformer, source transformer. Okay. So this is a three-phase system, star-connected three-phase system. Now from this source three-phase system, if we want to have the two-phase, then what will be the scheme? So that is the connection here. We have seen the right side load connected part. Here you see that secondary is load connected. So here you see that two single phase transformer is there. One single phase transformer is this side, load is connected, upper one. Another vertically, another single phase transformer is the horizontal one. But the single phase transformer of the horizontal one are 50% tapping. That means 50% is left side between C and D in primary, 50% is between B and D. So it will have a tappings on the 50%. And the other transformer cannot have the tapping. So that is may not have or may have tapping. Now you see that if these two transformer primary, one transformer primary, that means A, other end of the transformer is connected as a D. Where it is connected of the second transformer in the middle portion, that is 50%. Okay. So now you have seen the primary of the two transformer connected to the three phase. Okay. Here three transformer winding is here for the source, but in case of the Scott connection, primary side is two transformer primary. One transformer here, you see that horizontal one. Normally it is called main transformer. Another transformer is called vertical one. But their primary are connected like that way that it is forming a T type, T, okay, or T, inverse T. And the three ends, that means A, B, C, these are connected with the three lines of the source, three-phase source. So this is the primary section of the Scott connection. So what is then the connection? Connection is there are requirement is two transformer is required, single phase. And this two transformer is isolated from, that is individual transformer. Transformer 1 you can say transformer 2. The vertical one is called the teaser transformer and the horizontal one is called the main transformer. Now what is the basically operation? Now we'll go for the operation. Now you see that secondary are connected with the load. So secondary of the main transformer is connected with the load. Now if the transformer is 1:1, both the transformer is 1:1, that means primary and secondary are having the equal number of turns, that is called the 1:1. Now we will go for the phasor diagram so that you can understand. So now if we see the phasor diagram, so here this thing I will send you so that you can understand. So now you see that VAB equal to, here is the one thing you can say that VAB, V capital AB equal to VAB plus VGB. Why it is written? Now we go for VAB into the diagram. Here you see what is VAB. VAB means voltage between primary side A and B. So what will be that voltage? That voltage will be obviously VAB will be obviously AD, and then BB. These two voltages there will be. You can see that it is a Kirchhoff's voltage law. Very simple. Between these A and B of the primary, because all the three of the winding times what we have seen into the primary are electrically connected. So voltage will be following the Kirchhoff voltage law. So KVL. So that's why VAD plus VDB will be equal to VAB. Obviously. Now what is the VAB? VAB basically voltage between here in the source we say that it is voltage between A and B, that is you see that is a line voltage. So here you see that between the terminals of the small AB and small AC of the source, these are called the line voltage. So line voltage VAB can be resolved in two components. One is called VAD, another is called VDB. So now we will go for that, how they are taking part. So here you see that VAD, what will be then the VAD? VAD can be now VAB minus VDB. Okay, it is a very simple. Already you have seen from this you see that upper equation. So you see that from the upper equation, then the VAD is equal to VAB minus VDB. Now all are phasor, okay. Minus VDB minus VDB can be written as VBD. If we say VBD, DD, here DB, here BD. So minus of DD, it can be written VBD. So here we say that VAD is equal to VAB plus VBD. So from this equation, you can say that VAD is definitely equal to VAB plus VBD. Now we say that here is the equation from this we can say. So here you say that three-phase voltage are taken like this. Suppose this is the VAB source voltage, this is the VBC source voltage, this is the VCA source voltage. So how they are aligned? They are aligned like this. So VAB is plus 120 degree and VBC is horizontally 0 degree and VCA is minus of 120 degree. So this is the, now we can write the same voltage is coming as into the figure. This is the source voltage. As the same voltage is coming here, okay. So into the figure, if we see into the figure, you can say that here the same voltage. So VAB basically coming onto the electrically connected AB. So VAB can be taken here as VAB. Similarly, VBC can be, small VC can be V, capital VC like that, VC is like that. So thereby, the source voltage is like this. What we have said that source voltage, you can see that source voltage is like this. So these are called the source voltage. Then these are the expression of the voltage. VL is called the line voltage. So VBC is equal to VL 0 degree. Here you see the horizontal one, it is capital VBC also same. Then VBD will be half of VBC. You see that it will be VBD. What will be VBD? Here see, you see that VBD into the diagram. If the VBC is equal to this, VBC is equal to 0 VL 0 degree, then VBD will be half of VL 0 degree, okay. Thereby you can say that it is. So now we put the all of these phasor what we have obtained here. So you can see that these are the magnitude of the, then the VAB is equal to VL 120 degree I have told, VC is equal to VL minus 120 degree. So thereby on this equation, if we put, then you say that VAD is equal to, already I have told, VAD is equal to VL 120 degree. Here you have seen a plus, and the VBC half of VBD is equal to half of VBC, that is VL 0 degree. Now if we resolve it, the V 120 degree, that will be the 120 degree will be cosine 120 degree, J sine 120 degree, so minus 0.5, J 0.866. Now we will replace this angle by this, then you can say that, and what will be VAD? So VAD will come like this. You see that VAD will be coming, VL is equal to this, and then J equal to F, and J is equal to an operator plus 90 degree. You can say it is equal to VAD is equal to 0.86 is VL 90 degree. So you see that 0.86 is VL 90 degree. Now this is called the VAD. Now we can draw the phasor diagram of this. So here we can draw the phasor diagram. So VAD will be 90 degree, and VBC will be a 0 degree. And both secondary, you know that already I have told that EMF induced, all are actually taking as EMF induced. So EMF induced of primary and secondary are onto the same direction. So there are secondary also will be onto the same direction. You see that. You see that into the diagram. You can say that into the main diagram. If we go, you see, try to understand here main diagram. I am talking like that. So secondary and primary induced EMF always in same phase. I have already done this onto the first class or second class. Similarly, primary and secondary voltage will be onto the same phase. So if the VAD induced EMF is this, then the induced EMF of the secondary will be the same. So the VAD will be, if it is a 90 degree, then secondary voltage also will be 90 degree. If the primary voltage VBC is 0 degree, then secondary voltage also will be 0 degree. So that means there are two voltages generated into the secondary. One is as 90 degree AD, another is 0 degree VBC. So that is called two-phase system. Got it? Hello. So that is called two-phase system. So two-phase voltage are 90 degree out of phase. Normally the upper one, this is called the leading. It is a plus 90 degree, so leading. So this transformer is called the teaser one, and what is the 0? That is called the main transformer. So that is called Scott connection. You have to explain the Scott connection by this way, drawing the phasor diagram. So how the phasors? So these two phasors actually secondary VAD and VBC. You see that these two phases are out of phase 90 degree. That is called the two phase. So that is the. So we have obtained the two phase out of the three phase. However, three phase voltage is applied three phase here, but secondary we have got a two phase. So that is a very interesting part. So from this three phase to two phase. So that is the part here. Now what is the problem of this connection? So you see that problem is that you can go to the circuit here. In the circuit you will see what is the problem. Here you see that what is the problem. You have seen that VAD voltage is 0.866, 90 degree, 0.86. So this voltage is 0.886. So when the connection is this, then this voltage should not be line voltage. Okay, this voltage should be 0.86. Whereas VBC is the full line voltage. So two primary of the transformer are in different trans ratio. So one voltage is the 0.686 is 86%. But 1:1 transformer I have told you that will be the 1:1 transformer. So what does it mean? Well, that means if you have to select this teaser primary 86% of the main transformer. If the main transformer equal transformer, both equal transformer we have an equal transformer, that means the same rating transformer, then when you are connecting this teaser one, you have to use the 86% of the primary one, not the full one, okay? Because vectorically it is coming 86%, not full line voltage. However, here we can apply the full line voltage. So that is the two special case. So we cannot interchange the both transformer unless it is a 50% ratio, okay? So one is 50% tapping, another is 86% tapping we required into the primary side. Now, what will be the, however, it is 1:1 transformer. We have taken the tapping, 86. Some taps are not used, okay, unused portion. We will use the primary 86%, not 100%. That is the main use of this teaser one. Now, already I have told you that there will be the MMF relation of primary and secondary. If we load the secondary, then primary will be reflected. Load current will be reflected into the primary side. Here also the secondary load current will be reflected into the primary side. Another interesting point is here is that the neutral point is current 0 into the source, three-phase source. What is the balance case? What is the current to the neutral point? Is 0 current. But here you see that D as if the common connection of all of this. But here you see whatever the current through the AD, that is going to with the other. It is leaving B terminal, also leaving C terminal. Half of the current is leaving the right side, half of the current is leaving the C side. So that means we can say that the teaser transformer primary current is going through the main transformer primary, but that is, it is affecting the main transformer primary. So one transformer current is affecting the other transformer primary. So what is then the complication? So if the primary of the one transformer is taking the current from the other transformer primary also, so that will become a problem. But here is the problem is solved only because you will see that current from D is going to opposite direction. That means it is going to the right side direction, leaving the B terminal, and it is going to C terminal. So as MMF and the current is half, so MMF of the current of the primary of the teaser transformer is not affecting of the primary of the actually mathematically it's not affecting, because both MMF as the current are opposite direction through the turns, so their MMF or magnetomotive force will be opposite, in that sense equal amount. So net magnetomotive force contributed by the primary of the AD, that means will be 0. So in that sense we can say that it is not affecting there. So they are acting individually. However, another problem is that here you will see that the neutral point is here, but here you will see that it is 86%. So neutral will be shifted from this. D is not neutral here. Neutral will be shifted here. You can see that mathematical also. You see that, and another also that unbalanced MMF relation. Although their terms are equal, but the number of terms are different in primary and secondary, because number of turns of the teaser primary is 86%, whereas it is 100%. So when secondary current is reflecting into the primary, so then there will be the different ratio. Okay, but in case of the main transformer, as the primary 100% used and secondary also 100%, as it is a 1:1. Here you will see that the reflection will be in equal amount, but here it will be unequal amount. So how this is affecting, so that can be said. So what will be the GA ratio of the secondary of this teaser one? Small AD. Suppose it is loading, so it is a I2 current flowing, and the turns is N2. So what will be the MMF? That will be I2 into N2 for the teaser secondary. But this is called the VA, V2 into I2. But in case of this, so what will be then the V2, V1? V1 will be 86% of the V2. It will be 86% of the V2. And current will increase because turn is when the turns is less, current will be increased proportionately. So proportionately, the current will increase. Ultimately, it will be V2 I2. So that mathematically also can be proved here. You see that you can go here. So you have to understand that is the Ampere's law or the MMF balance equation. Already I have told you. I have shown you a balance equation. So here you see that this is the, so into the primary, secondary current is the N2 into IAD. IAD means secondary, small letter secondary, and terminals N2. But in primary it will be IAD into turns will be 0.866 N1. That means N1, say N1 is the primary turns. If it is an unequal ratio, then we can say that N1 into N2. So this will be the primary MMF. So what will be IAD? IAD will be this right hand side. Here you see that 1.15, 111% will be the increase of the current of the primary side. So if the current 100 ampere into the secondary side, then primary side current will be 111.5 ampere. And if we say that turns ratio equal, that will be the increase. And if we end to end, then this will be the 1, then it will be the current. So this is called the current transformation. So you have to use that. And whereas in the secondary of the main transformer, both are equal because N1 to N2, IBC and IBC, they will have equal ratio. So both currents are equal. So teaser and primary and secondary are equal. Now we will try to solve a problem. Okay. So now another problem is that the secondary current of the one side will be minus of IAD. That means D, from D current is dividing to both sides. So one current will be additive, another current will be subtraction. So this is the equation, current equation 8.1. So minus. So also vectorically you can see that. So if the current is IAD is like this, okay, there is upper IAD. So that current will be coming from this side. So minus of this current. So that will be one part will be the minus of IAD. So you see that this part. So this is suppose the IBC. This is the minus of IBC. This is current is the IBC. Then this will be minus of ID, vectorial sum of this. So that will give the total current. One side current is I phasor is there, another current is there. So this is the three-phase input side current. However, secondary load current is there. So both current of the secondary will be in phase. Suppose the unity power factor load, then this will be the current of the secondary of the teaser 1. This will be current of the voltage of the secondary of the teaser 1. However, when these are reflected into the primary side, so those will be the minus because you know that the direction of the current inverses when primary to secondary, direction of the current reverses. So that's why it will be minus. So current will be downward in vectorically, but it will be half of current will be coming with the BC, half of the current coming with the minus of BC, half of the current with the BC. So these will be the vector sum of the three currents. So three input line current will be, one will be the IAD here, another current will be IBD here, another current will be ICC here. So vectorically you have to find this current. So this is the numerical basically you have to solve. Here numerical you can solve it. So similarly another problem is sometimes current is lagging. Suppose voltage is here, current is, suppose here is the secondary. Suppose here is the secondary, you see that secondary voltage and secondary current. So it is a θ1 angle. Here is a θ2 angle lagging both of the voltage of the both of the secondary. So load is like that. So it is a lagging power factor load. So in that case again IAD will be minus of this. You see that there will be a 180 degree out of phase with the secondary into the when it is coming capital IAD in primary side. Here also it is coming primary side. So resultant current will be one will be this, one will be this. These are the line current. Another will be this. So these are these three line currents. In numericals, you will have different type of problem on depending on that. So now we are sending this material to you. You can read it and understand it. So today I am doing up to this Scott connection. So there is another problem also. You can solve it. Many problems given because in exam you will find the problems, numericals. So you can solve it in component form also. So there are various solutions. I cannot take all of the solutions. So there are the various solutions. You can take it. So what are the pages now? Pages 16. So ঠিক আছে তাহলে এখানেই ক্লাস শেষ হলো আজকে বৃহস্পতিবারের ক্লাসটা হবে না, আবার সামনের সোমবার হবে। হ্যালো, কেউ যদি থেকে থাকো, জানি না আছে কিনা, পালিয়ে গেছে তো।
Okay, sir.
আছি স্যার।
আমি আমি পাঠিয়ে দিলাম ওটা। ওটা তোমাদের দেখতে হবে, মেনলি এই স্পট কানেকশনটা নিজেরা একটু ড্রয়িং করে করবে, কারণ নিউমেরিক্যালস আমি যেটা দেব সেটা কিন্তু একটু মানে কনসেপচুয়াল হবে, পারবে না যদি এখানে যেভাবে করা আছে নিজেরা যদি ফেজর ডায়াগ্রাম করে নিজেরা সলভ না করো, আমি যেটা দেব কিন্তু পারবে না, একদম সিম্পলি পারবে না, একদম লেজে গোবরে হয়ে যাবে। ফলত তোমরা একটু এখানে মানে একটু দুই একটা প্রবলেম যেভাবে আছে, না বুঝলে আমাকে কনসাল্ট করবে পরের দিন। আমি চেষ্টা করছি কি যে এই ক্লাসগুলো রাতের থেকে দিনে নিয়ে আসার, জানি না সম্ভব হবে কিনা, কারণ ইউনিভার্সিটি আমি যাচ্ছি প্রতিদিনই আমি অন্তত ইউনিভার্সিটিতে যাচ্ছি, 5টা অব্দি থাকছি, তারপরে চলে আসি যদি 5টার মধ্যে সম্ভব হয়। আদারওয়াইজ সোমবারগুলোতে এই ক্লাসটা হবে, কারণ বৃহস্পতিবার আমার একটা প্রবলেম হচ্ছে কি, আরেকটা ক্লাস ওই সময় দরকার, মাস্টার ডিগ্রি 2টো ক্লাস দরকার আমার, একটা হচ্ছে টাইমিং মিলছে না তোমাদের 2 দিন নেওয়ার জন্য, তো সেই জন্য আমি বৃহস্পতিবারটা ছেড়ে দিচ্ছি, সোমবারটাই হবে আপাতত। আর এইভাবে আমি মেটেরিয়াল দিয়ে যাচ্ছি, তোমরা দেখো যদি পড়ে না বুঝতে পারো। প্রত্যেকের আমি দেখলাম যে পেন ড্রাইভে, তাছাড়া পেন ড্রাইভ আমার এখন কাজ করছে না, আমি মূল প্রবলেম করেছি পেন ড্রাইভে। তোমাদের মেশিনসটা নয় পড়ানো যাবে, ফিল্ড থিওরিটা আমি জানি না তোমাদের কতটা কি হচ্ছে। ফিল্ড থিওরি কি তোমাদের হয়েছে কিছু? আমি তো অন্য সেকশনে ফিল্ড থিওরিটাও নিচ্ছি।
হ্যাঁ স্যার, ফিল্ড থিওরি ওই ইলেকট্রোস্ট্যাটিক্স পার্টটা শিবাজি স্যার নিচ্ছেন।
আচ্ছা, আমি ইলেকট্রোম্যাগনেটিক্সটা নেই, তো আমি অন্য সেকশনে নিচ্ছি, সেখানে আমি ওই মানে লিখে লিখে করাচ্ছিলাম, কিন্তু এমন সমস্যা হলো তোমাদের ওই জ্যাম বোর্ড, এখন জ্যাম বোর্ড আমাকে লিখতেই দিচ্ছে না, মানে লিখতে গেলে আমি পারছি না, জ্যাম বোর্ডে লেখাটা হচ্ছে না, পেন ড্রাইভটা এইটাই কাজ করছে না। এখন দেখি ওদের জন্য আবার কিভাবে কি করাতে হয়। এখন কিছু করার জন্য এই সাবজেক্টটা যদিও মেশিনটা যদিও বা দিতে পারবো মেটেরিয়াল, ফিল্ড থিওরি মেটেরিয়াল দিলেও লাভ নেই, ওরা বুঝতেই পারবে না কি হচ্ছে। আর এই পার্টটা আমার এই যে অন্য পার্টটা কবে শুরু হবে কিছু বলেছেন?
স্যার কি মেশিনে?
না না, ফিল্ড থিওরিতে
ও না, ওটা এখনো কিছু বলেনি কেউ।
যোগাযোগ করতে পারোনি?
স্যার ওটা তো স্যার সিআররা করে, আমি জানি না সিআররা কি করছে এখন।
আমার মতে কি করবো কে জানে। যাকে ওই সাবজেক্টটা তোমাদের ডুববে তাহলে, তার মানে যদি সময় মতো না টেক আপ করো, যাকে তোমাদের ব্যাপার। তাহলে হ্যাঁ, আজকে এই অবধি, হ্যাঁ পরের সোমবার আবার হবে। হ্যালো, ঠিক আছে,
ঠিক আছে স্যার, ঠিক আছে
আমি
স্যার।
থাকছি, হ্যাঁ।